Okay, what we have here are 3 acids. We have 6 molar sulfuric acid, 6 molar acetic acid, and 3 molar hydrochloric acid. And these are poured into 4 containers. The 6 molar sulfuric acid is here, the 6 molar acetic acid here, and the 3 molar hydrochloric acid are in these 2 containers. And what I also have in this box are some samples of marble and a sample of granite. And so what I'm going to do is I'm going to take that granite sample and put it in the hydrochloric acid. And looking in here, we don't see a whole lot going on because, well, it's aluminosilicate doesn't react very readily with any sort of acid. Now we're going to take a sample of marble and put it in this hydrochloric acid, and we can see that there's a reaction taking place. Alright, and we're going to put this marble sample into acetic acid and this marble into the sulfuric acid. Alright, we're going to let that go for a little bit, and we're going to take a little walk over to a nearby cemetery and talk a little bit about the chemistry taking place in the headstones of the cemetery. Okay. These headstones have been around for a long time, been subject to all sorts of weathering activity, acidity in the rain. And you have 2 headstones here. The granite headstone is on the left and the marble headstone is on the right. And you might be able to notice from this that there's a difference in sort of the sharpness of the features of the headstone. The marble headstone on the right is a lot softer, less well-defined features in the granite headstone on the left. And if we take a closer look, we see that this headstone is dated 1868. I don't know if you can see that in the video. It has very sharp edges. This is the granite headstone. And the marble headstone here, it's really hard to see the writing even though with the light shining on it. I believe it's 1882. So hypothetically it's a more recent headstone. I cannot say for sure that this is the original headstone. I don't have that evidence. But you see this sort of phenomenon taking place in a lot of cemeteries where the marble headstones have more soft features because they're being eroded away more by the acidity and rainwater than the granite headstones. The marble has calcium carbonate. It's mostly calcium carbonate, which reacts with the acidity and the rainwater. The aluminosilicates in the granite do not tend to react near as readily. So let's head back to our experiments and see what's happening. I didn't want to do this chemistry in the cemetery. It will be a little uncomfortable to do that. But again, you see this sort of chemistry happening in all sorts of cemeteries. Okay, so let's go back here and see what's happening. Alright, you can see the aluminosilicate is not reacting, the granite is not reacting with the hydrochloric acid, but you can see that the hydrochloric acid and the marble are vigorously reacting. That calcium carbonate is reacting with the hydrochloric acid to produce carbon dioxide gas. Taking a look at the acetic acid, you might be able to see a little bit of bubbling taking place. Now, the concentration of the acetic acid is twice that of the hydrochloric acid. Why is it bubbling more slow? Well, that's because the acetic acid is a weak acid, doesn't dissociate into ions nearly as readily as the hydrochloric acid, which dissociates completely into ions. And so there's a lot more free hydrogen ions in the hydrochloric acid solution to interact with the calcium carbonate of the marble. So let's move on to the sulfuric acid. Sulfuric acid is a well-known strong acid, and it's a 6 molar concentration, so it's twice that of the hydrochloric acid. But if we look in here, again, it doesn't look like there's a whole lot happening. There's a few bubbles I can see on the surface of the marble, but it's remarkably, and to me surprisingly, unreactive. Okay, our best guess as to what's happening here is the sulfuric acid is reacting with the calcium carbonate to produce calcium sulfate. And calcium sulfate is material you find in plaster. And what appears to be happening is the sulfuric acid is probably making a bit of calcium sulfate on the surface of the marble and slowing the reaction down. So sulfuric acid, which is a major component of acid rain, will react with marble, but apparently the process is a little bit slower than I anticipated, because it first makes this soft calcium sulfate, which eventually wears away. And again, we all know those marble headstones are getting eroded away in cemeteries much more rapidly than granite. So I guess if there's any lesson to be learned here is, one, a little bit about weak and strong acids, but also if you're going to find yourself a headstone for a cemetery, if you want one to last a long time, go with granite rather than marble.